Hello and welcome to T2 Day 23 of Honors Precalculus. We're going to continue talking about our journey through parametric equations with one question today, and it's a Ferris wheel question. It's pretty cool. So a 20-foot Ferris wheel turns counterclockwise. And what does that mean about 20 foot? It's really important here. We're talking about this distance right here, which is like the radius of the Ferris wheel, and it turns counterclockwise one revolution every 12 seconds. So that's also really important. One revolution every 12 seconds. Eric stands at point D, which is 75 feet away right there from the center, straight underneath the center of the Ferris wheel. And when Jane is at point A, which is right here, it's not super clear, but it's going to be right here at this height right here when it's exactly at kind of like the 3 o'clock on the Ferris wheel. Eric throws a ball, releasing it from the same height as the bottom of the wheel. So it's the same height right there. Initial speed of 60 feet per second and releasing at an angle of 120 degrees. Does Jane have a chance to catch the ball? So what's going on here is Jane is going around this Ferris wheel. So at certain times she is just going around and around and around, and the ball is being launched up, and the ball will have this path like this. So we're going to try to figure out, does the ball ever get close enough to Jane that she has a reasonable chance of catching the ball? So first of all, let's model the Ferris wheel with a parametric equation. And the way that's going to come out is the x value, the horizontal position of the Jane in the Ferris wheel, first is going to be 20 cosine of pi over 6 times the time. Now, where does that come from? You end up with pi over 6 because of the 12-second rotation. You get that from what you might remember, that period is 2 pi over b, where this is the b value. And when you fill in 12, you end up with b is pi over 6. So that's where that comes from. That's her horizontal position if this is time equals 0 for her, time equals 0. Now her vertical position, her y position, is going to be 20 sine of pi over 6t, but you have to add 20 to it because at time equals 0, she's starting at a height of 20. So that's the Ferris wheel. That's her position on the Ferris wheel with respect to time. And remember, this is in radians right here because we used pi over 6. Now, the ball, similarly, x1 in this case is going to be from yesterday. When I say similar to yesterday, we're using the formula from yesterday. It's going to be 75 minus 60 cosine of 60 degrees t. And that's the formula we got yesterday for a ball with regular Earth gravity here. And the vertical position, which is where gravity comes really into play, is negative 16t squared plus 60 sine 60 degrees t. And the reason you get that is the angle measure here. So when it says it's released at an angle of 120 degrees, it's actually measuring this right here at 120. The formula we have from yesterday needs this angle right there. So the important thing is this is where the ball is at time t, and this is where the person, Jane, in the Ferris wheel is at time t. And keep in mind also that this is in degrees right here, so when we're plugging this into our calculator, we have to be careful that we're in the right mode. So we use the formula from the last video to write both of these as parametric equations. So what's going on now? We need to figure out, does the ball ever get close enough for her to catch it? So we need to know the distance between the Ferris wheel, in this case Jane, so let's call her Jane, the distance from Jane and what's the distance for her and the ball at a given times t. Well, just remember, if you have 2 points, let's say 2, 3, and 4, 5, if we want the distance between them, we would do the square root of the distance between the x value, so 4 minus 2 squared plus 5 minus 3 squared. That would be the distance between those 2 points, and we really have 2 points here. We do. Here's our first x value. Here's our second x value. Oh, I need to call that 2. Sorry, that should be called 2. And here's our first y value, and here's our second y value. So the distance between them is actually going to be the square root of x1 minus x2 squared. And you can do it in either order because when you square something, if it's negative, it becomes positive. y1 minus y2 squared. So it's just going to be big. That's all it's going to be, and we're going to have to use a calculator for this. So if we write this whole thing out, and just remember, this is going to be the same thing as flipping. So you can do either way as long as the x's are subtracted from the x's. You could do it like this if you wanted to. That's totally fine. They're both the same. But when you write this out with these 2 points, it's basically 2 points that are moving. You can find the distance between them, and then we're going to minimize that equation. This big thing right here, that's what you get. Now, when you evaluate this, what's going on is this is the distance between them at time t, and it's big and nasty. You just need to evaluate carefully. So for example, you know that cosine of 60 is a value you should know. Cosine of 60 degrees is just 1/2. Cosine of pi over 6, cosine of pi over 6, you have to be super, this should be written, I wrote it a little messy here. This is t right here, it's pi over 6t, that thing, whole thing squared. So we can't evaluate that, but we know that sine of 60 degrees is root 3 over 2 right there. So you can plug those values in, and then this function right here, we want to know when is it minimized. So this would be the closest the ball gets to Jane. And if you do this out, it's minimized at 2.185, comma 1.579. And remember, this is going to be the time right here. This is going to be the input time, and then this would be the distance. So if this is in feet, the closest it will come out to be is 1.579 feet from Jane, and that seems about reasonable for a distance that she theoretically could catch. Now, we're not factoring in speed here, but that's what it is. The way you do this is you would put 1/2 into here, you'd put root 3 over 2 into here, and then you'd have to graph this and take a look where the minimum occurs. Find where the minimum occurs. We will play with this. So just remember, when you're doing this out, this comes from the equations from the last video. And then when you're doing this, circles are going to have sine and cosine, because when you square cosine and sine squared, you're going to get the radius squared. So that's where this comes in right here. And then the pi over 6 comes from the 12 right there. Once you build this, you have where each of these things is as a function of time. And then this right here is the distance, this big thing right here is the distance between them as a function of time. And then we're going to minimize it, find when it's minimized using our calculator. This will take practice, and we just got to do it carefully.